So let's look at this question here, which is on the application of integration. I think the first one is pretty okay. Find the exact value of 0 to 1 of this integration. This use MF26, so this one is a giveaway mark. In exam, if this comes out, just know that you can use MF26, alright? Then what you do is actually just bring out MF26 and just find out this integral here. Integrating 1 plus x squared would be tangent inverse x, okay? So there you go. So this part here would be tangent inverse x bracket 1, 0. I think this is nothing like interesting here. Tangent inverse 0. So this will be 45 degrees. So this will just be pi over 4. And that's it. Okay. Quite a straightforward question here. After which we're going to look at part 2. So you are given that the graph 1 plus y squared 0, 1 is shown as in the diagram below. The rectangles, each width of 1 over n, are drawn under the curve. Show that the total area A is given by this expression here. State the limit of A as n goes to infinity. Okay, that's pretty okay. So this is actually the width here. So we're going to find out what is this graph here is y equals to 1 plus x squared. Okay, and each width of this rectangle here is 1 over n. This width here is also 1 over n. This width here is also 1 over n. Okay, now what you need to take note is actually, if you want to find the area of rectangle, you just need to find, area of rectangle will just mean that you need to find the height of the rectangle, right? And we will cover this in our when we are doing our revision. So what I will suggest is actually just know that the height here, we're taking the right bound for this case. So there are two ways of taking the height. One is you're taking the left bound or the right bound. Typically in the questions which you'll see in A levels, right? There are two ways. So the one on the right will just mean that the height here, you want to register this height here. It will just substitute x equals to 1 over n in, because that will be 1 over x in, right? So the y value here will be 1 over 1 plus 1 over n square. Okay, this is it, the height of the first one. So let me just write it down. State a rectangle. Okay, so hence part 2, what you need to write down is actually total, so A, sum of area of all rectangles, right? So I'm going to take the first one first. The first one, I know that the width is 1 over n. The second one would just be, this is y, right? So this is where this is 1 over 1 plus 1 over n square. This is the height. Okay, so if you just see carefully, it's just basically base, which is 1 over n, times the height, which is 1. This is it. Then you're going to register the second one. The second one here, this is where x equals to 2 over n. So this case here, the height will register as 1 over 1 plus 2 over n square. Okay, so there you go. So this case here will be plus the width is the same, so it's just 1 plus 2 over n square, like that. Okay, then after which, what we need to do is that the third width is actually 3 over n. Do you see that? This is 3 over n. So the height here is 3 over n. So we're going to take this as 1 over n and 1 plus 3 over n square. And so on the last one, we'll have the same width, right? But the last one, the height here, as you can see here, this is the last height, which is actually 1 over 1 plus 1 square. So the last one will be 1 over n, 1 over 1 plus 1 square. Okay, so they all have the same width but different height. Okay, so that's how you see that. So now what we need to show is taking the 1 over n out. So this case here, I'm going to just factorize 1 over n out. 1 over 1 plus n square plus 1 over 1 plus 2n square plus 1 over n 1 plus 3n square plus dot 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 plus 1 over 2. Okay, there you go. This is it. That's how you find this formula here. After which, we were told to state the limit of this graph here. So I'm going to visualize this using the applet on this website here, MathWorld, Wolfram. What you do is actually from this graph, I sketch from 0 to 1 the number of rectangles. As you can see, if you use the lower resolution, so let's say if you use 10, the graph will look something like that. Alright, now if you were to use 5, the resolution here, this is what we call underestimation. Now you can take the boundary on the right or the left or the middle or but typically in our syllabus we are taking left or right. So in this case, if you take the one on the left, it will be an overestimate, but if you take the one on the right, it will be underestimate. But generally, if you were to take more and more rectangles, so let's say if you pick 100 and replot, you realize that actually what happens is, okay, couldn't, too many, so just replot again, maybe 50, yeah, there you go. You see this area would just become the actual area. It will be very close to the actual area. You see, this is the actual area and this is the estimated area. So the estimated area, as n goes to infinity, A will become the exact area. Okay, hence, what is it called? Limit of A equals to pi over 4. That's all. It becomes the area that you found in the first part. Okay, that's how we do that. So let's look at the third part. You're told that B is given by 1 over n, 1 over n4, and so on. So by using the aid of a calculator, you need to show that when n goes to infinity, that what is the value of B. So we need to, how do we gonna key this series into calculator? We need to express this in terms of sigma notation, right? And try and find the general term here. So for B, basically what happens is actually 1 over n. N is a constant in the way, by the way. So this case here, what is running is 1, 2, 3, right? And basically, because n goes to infinity, we're going to sub n very big value. But here, what I can write down is actually, if n is a constant, this would just be, let's say, k, or r, or n it will be, is actually n, because you have n terms here. Okay, right? You have n terms here, right? N times. So this is n, and you start off with 1 and ends with 1 here. So this case here, if we want to do this, it will be, the general term will be 1 plus r over n to the power of 4. Okay, this is the formula here that we're using, n. So you just check. So the last one will be 1 plus n over n to the power of 4, right? So that's how you get this form here. R, okay, R, great. So the thing now is, this is our general form. So in order for us to key in the calculator, what I'm going to do is actually just going to put, I'm going to put n, okay, then after which I'm going to just compute and see what my calculator will give me. From this case here, I got 1, I'm going to use summation, just slowly. This case here, what I'm going to do is math, just press this as summation here. Then alpha, this I'm going to use this as r first. Where's my r? OPQ r1 to n. Okay, so n here, I'm going to use any constant n here. N. Okay, n. Okay, this is n. Then this is 1 over 1 plus r over n. So I'm going to just 1 plus r over n. So this will be alpha r over n. Okay, to the power of 4. Okay, then after which this whole thing need to multiply by 1 over n in front, right? Okay, great. So now we need to talk about how do we actually store a value for n, right? So if you say you want to store a value for n, so 10, should storage and n. You see this? Store this one. Store. So wait, just if you want to store value to n, so you just press storage here and press alpha n. I think that's it. So so if you put n down now, it will be 10. Okay, so that's how to store the value in. But if you don't really like this method, you could actually just put n as 10 if you want to. But of course, n is not huge, right? This is not really a big number. So what we can do is actually just put 1000 maybe. And then I'm going to store it under n. And I'm going to try and key this in again and see what I'll get. It can take a while, but hopefully you'll get a number which is like good to go. Okay, so I'm just still waiting for the answer. Wait for the answer. There you go. The answer is 8667229. Okay. You could use maybe in exam you just key in and you just wait for it, because they need to keep interpolate it and try and put the to calculate it back, and it's gonna take a while. So I think this is a pretty close answer here. So this is from GC 8.8667. Therefore from GC 2. Okay, so this will be 0.867 3SF. Okay, so this is how to do this question here proficiently. Any question at all, please let us know. Keep practicing. I'll see you in the next question.